Welcome to our very exciting community call today, where we are talking about data access for your AI. My name is Rob. I'm an engineer here at Hasura, and we're very excited about this launch day that we have. Happy Halloween to everybody celebrating. Happy Diwali to everybody that's celebrating as well. Big day for a lot of reasons, but we think it's going to be a big day because of talking to your data. We have a pretty short agenda, but it's packed with a lot of information. We're going to begin with a keynote from our CEO and co-founder, Tanmai Gopal, where we are introducing our new product, PromptQL. We'll go through a couple of use case examples, in particular, looking at how we can make better data-driven decisions for engineering management, and then also how we can do more effective customer support by using these agentic tools for access to data. So without further ado, I'm going to go ahead and turn over to the man, the myth, the legend himself, and it'll be very easy to spot him because this color has become quite common around the office over the past few days. But Tanmai, go ahead and join me on stage, please.
All right. So excited. It has been a year. It has been a year and a half since we started exploring AI stuff. I don't know if you folks remember the stuff that we were exploring and that we kind of shared during HasuraCon last year. And since then, we've just been going deep in the entire ecosystem and trying to take a look at what's happening, what's working, what's not working. Where is that the big opportunity that is going to be created by AI? Where is it hype? Where is it real? How what is kind of some of the biggest challenges, especially when it comes to data that we can look at? And so today I'm super excited to introduce some of the work that we've been doing. It's in alpha, and so I'm going to kind of just walk through that a little bit, do a little bit of a live demo, and then tee off into some more updates across the rest of Hasura and DDN and GraphQL as well. So cool. We are familiar with GraphQL, a lot of us, and so when we were kind of thinking about what data access would be for AI, PromptQL, as the name presented itself, it's very interesting. It's based on the same thing, underlying metadata that Hasura is, but as opposed to exposing a GraphQL API, it exposes a PromptQL API. API is not strictly the right word, but sort of API. The big observation, and I'm sure you folks have seen this as well, and let me know in the comments as well. And I always ask this question to people, and I'm very curious about knowing what AI products are you folks using day to day that is not an assistant like ChatGPT or Claude that's kind of baked in, right? So I mean, I've started using Cursor quite a bit, and I enjoy it a lot. But I'd love to hear of what AI products that you folks are using, especially at work, especially to kind of automate things that are interesting. And it's been an interesting experience of trying a bunch of this out over the last few months. I think. Thank you. One of the things that seems to be kind of a recurring pattern is that a lot of the AI products that are connected to data don't perform well, especially with real user queries. And this kind of leads to a challenge where you don't necessarily trust the AI product that you're building or that you're using, right? If you folks have access to Gemini on Gmail, you should try these queries out live. Or go to Amazon.com and you have the Rufus assistant. If you folks use Salesforce, Salesforce has something called Einstein. And try out a bunch of kind of reasonably straightforward queries, right? So for example, you say, what are my Uber receipts from October like, or, did I have any follow-ups last week that I've missed in my email? And you'll notice that it sort of works. It gives you an answer, but if you look at your email inbox and you compare it to the answer that you got, you're like, no, you missed this out and you didn't tell me about this, but you told me about this other thing that's not very relevant. If you ask Amazon's assistant about, I buy coffee very often, should I switch over to the subscription buying coffee thing? Can't help you, which kind of makes it a slightly useless shopping assistant. If you ask Einstein, Salesforce Einstein, precise questions or vague questions about stuff that's in your Salesforce, just says some wrong things, right? It says some things and sometimes doesn't say a thing. And then you ask it the same question twice and it doesn't have the same answer. And this performance is really, I mean, astonishingly poor, right? It's good enough in some cases, especially consumer use cases. But if you think about it at work and you think about it for your users that are using the product that you're building and the data that you have in a business critical way, uh, it's not it's not ideal, right? It's definitely kind of feels early, definitely feels like, we don't, is this ever going to work? Um, and and we put together what we call an agentic data access benchmark um, that we've been looking at, which kind of talks about a lot of the complexities of when you have data, structured, unstructured, whatever, and you have prompts and you have questions. Is your AI product able to figure out what to do accurate retrieval and accurate composition to help answer that question, right? RAG and vector-based kind of search retrieval is one part of this problem or is one approach to solving this problem. But really kind of how does it rate across different types of questions? So we kind of took a whole bunch of questions, categorized it in different ways, and they kind of talk about a lot of different stories, and performance across the board is really poor. It's under 20 to under 10% performance across AI systems that you look at that are live, right? And these are because the challenges that the things that we do as humans are quite complicated, right? We retrieve data from multiple places to do some work. We aggregate data from sometimes multiple places. We analyze things in bulk. We make decisions on the fly. And in a lot of these cases, things don't necessarily work very well. Kind of talked a little bit about why that happens, and you folks should head over to promptql.hasura.io to get a sense of, a difference between kind of canned retrieval and taking a look at an agentic approach to retrieval, which is what we've been working on over the last year. Now, what I want to do is show you kind of what this actually means and how good or how bad things actually are on the floor, right? So we had our sales offsite yesterday, and so what we did yesterday was we threw PromptQL on Salesforce, and we said let's see what it looks like. So we kind of took a few questions when we first ran it on Salesforce Einstein. So for those of you who don't know, Salesforce is a kind of like a CRM product. It helps you look at different sales opportunities that you have, what stages they're at, who you're talking to, when you might close the opportunity, how much revenue is associated with each opportunity, what the notes are, all of that stuff. And so if you go to Einstein and you ask it, tell me something about this opportunity, you get a little bit of an answer, which is fine. And then you kind of ask a follow-up question, which is, what are the next steps? Summarize the next steps, the action items for this particular opportunity, right? And you get a little bit of an answer, right? You don't get any next steps, and that's fine. But that's what this is like. Now, I don't know whether to trust it or whether to, is this good enough? Am I going to have to go back and look inside Salesforce for kind of solving this problem anyway? And so what we did was we threw PromptQL on this without any preparation, just kind of out of the box, and said, all right, tell me about action items and next steps. And the first thing that you notice is this part of kind of being able to kind of agentically create a plan is it spits out the plan and tells you that this is what it's going to do, this is what it's going to look at, and based on that, it's going to kind of help synthesize an answer. And if you look at kind of the quality of the answer, this is just a summary, I've taken some stuff off where this data is live, is it actually tells you, hey, this is the person you were talking to. This is kind of the state of documentation. Be prepared to discuss, how Hasura can handle their current scale and their potential future growth. What stage this opportunity is at. Just that level of detail and structure in understanding that is completely different. Now, while this is okay, maybe Einstein was still not wrong, right? You take another example, and we said, what is the average length of our sales cycle? How much time does it take for us to, get introduced to somebody, work with them, understand how complex their kind of setup is, and help them out and work out the right kind of deal for them? What does that look like? And so we said, for this quarter, what does our sales cycle length look like? And well, the first answer is meh. And then, as with all of you who would have used AI, you can always coerce, nudge, cajole the AI into doing things for you. And so we said, try again. And it said our sales cycle is 2 days. I mean, if you're closing large deals within 2 days and that's your sales cycle length, I mean, it's IPO time basically. That's insane, which is definitely not true, right? When you ask the assistant in AI of explaining how it got to a particular thing, it's the there is a little bit of reasoning that it shares, um, but you can kind of make out that it's not it's kind of retrieval, right? It wasn't it took that value, um, and it did more of a retrieval than actually kind of thinking about what that question really means, right? You look at the quality of what happens when we chuck PromptQL on this. You first get a pretty detailed query plan, right? Which says, hey, let's first understand what a quarter is. Let's get the quarter. Let's look at different kinds of opportunities, different kinds of people that we're talking to, and then let's actually calculate the sales cycle length and then present a summary of the different sales cycle length and variations that we're seeing across all of these users, which is nice because now I can also see what it's done and I know whether it's making a mistake or not, right? Like one of the things here, for example, is that it's taking the current quarter and I probably want to take the fiscal quarter, right? Our quarters at what our fiscal year doesn't end in December, it ends in January, right? And so, maybe that's something I'll have to double check while I'm working with this AI or nudge it in that direction. But you look at that kind of answer, and then you see something, and then you see kind of what that results in, and that feels like a much more legitimate answer, right? Enterprise sales cycle lengths are typically a year, 1.5 years long, and then that's kind of what you get to see, where it kind of breaks that down for you. It looks at different opportunities, the variation in length, and you can start to ask follow-up questions. You can start to look at the actual data that was looked at, that was analyzed, whether it was structured or unstructured. So that's kind of what we've been working on. I'm going to do a little bit of a live demo to show you how this is set up. And there's many points to take away here. Just look at the questions to see if something's come up. Yeah, I'm just reading some of the things that you folks have been posting. I think great question from Paulius, which is, what are the limitations, right? How many documents can you analyze? 1 million, 10 million? Does it provide sources and citations that are used to generate the answer? And how does the retrieval or answer generation time scale with the number of source documents? This is a phenomenally good question. And this has actually been, is a core part of when we talk about kind of agentic retrieval and agentic query planning, right? Just like how, Polly, just to your question, right, which is the size and the number of documents that you provide in the context when you're speaking with AI, you kind of, when you're talking to say ChatGPT and you paste 1 million documents into its prompt and ask it a question, you'll notice that performance degrades pretty severely with the size of the context window, right? And also the quality of the content that you have in the context window. PromptQL takes a very different approach. What PromptQL does is, depending on the nature of your query, especially if you have a large number of documents that you want to analyze, depending on the nature of the query that you have, it might turn out that the better way to approach this is to retrieve the right set of documents that you need, say 1 million, say 10 million, whatever that number is, and then perform an analysis on a right set of documents or just one document at a time. And what PromptQL does is that when it kind of does this composition, it doesn't store these documents in context, it stores it in structured memory. And when we do a demo, we'll take a look at what this structured memory actually looks like. So that means that you get the same quality of answer, whether it's one document, 10 document, or 10 million documents, right? So if you say, look at this document and extract something for me, or classify it for me, or summarize it for me, or tell me something about it, or answer a question, and you get a good answer, you're happy with the quality of what you get on one document, that is going to scale, right? how much time will it take, and etc. depends on the size of the document and what AI you're using and stuff like that. And you can plug in kind of your own AI system here. But the plan is kind of created depending on the nature of that, depending on the nature of the question that you're asking, right? One of my favorite examples, which is so easy to try out, is how, tell me if any emails from the last week need a follow-up. And you try this on Gemini, and you'll notice that the first thing that it does, and because you've asked this question, I'm going to go into detail because I personally like going into detail, anybody who knows me. So let's take a look at what's actually the situation, right? So when you say over the last week, tell me what emails I need to follow up on, right? What's happening is that Gemini is kind of doing a search for something related to follow-up. It finds a bunch of documents that are related to follow-up, which may or may not be the right thing. For example, if I sent you an email saying, hey, please get back to me, the word might not be follow-up. That results in a search match. And then you take all of that email context and you give it to an LLM and it gives you an answer. If you happen to have the set of emails that you analyzed after doing a search was 1 million emails, and a bad quality answer. If you have 10 emails, you might get a better quality answer. But not only are you dependent on the number of emails, you've probably missed out a bunch of emails that needed a follow-up but didn't have the word follow-up in it. What PromptQL does is a very different approach. What PromptQL says is, emails from last week. Let's look at my emails data. Let's look at its metadata. It has a time filter. Let's calculate last week. We know what last week is. Let's first apply the last week filter. Emails that need a follow-up. Are there any other filters I can apply? Yep. If you've already read the email, or maybe if you've already replied to the email, then we don't want to follow up. So let's filter out for things that have already been replied to. Now, let's get that set of emails. On that set of emails, for each email, let us use each email as its context. We're not going to send the 1 million emails as context. We're going to take each email, and that is the isolated context we create. And then the specific question that PromptQL prompts itself with, this kind of like this composition that's happening. PromptQL says to itself, classify this email as whether it deserves a follow-up or not. And now each email is analyzed with intelligence, where you read the content of the email and you're like, this needs a follow-up. Or nope, this doesn't need a follow-up. This looks like it's a spam email, or it's something that contains the word follow-up, but it's not about following up, right? And that suddenly results in an accurate answer, no matter how many emails you have. Of course, it's not going to be feasible to do this to your entire inbox for the last 10 years, so don't do it. You will run out of tokens very quickly. We've had a few interesting experiments where that has happened. So you want to make sure that there's rate limiting and stuff like that and whatnot. But you can control that, right? You can control the time window. You can set a maximum. You know that it's going and it's becoming too long. You can just stop it. You can do all kinds of the right things that you would do. But you have agency, you have control, and it's kind of doing the thing that you would do, right? If you were analyzing and solving this, which email needs follow-up problem. Of all of the things that were important about this, I think one of the things that I wanted to point out was let's not name our AI for products that and after people who won a Nobel Prize for their side project. Not even Einstein's real work, but Einstein's side project is what he won a Nobel Prize for. And the state of AI is quite far from being called Einstein. So that's an important takeaway, right? AI is not particularly smart just yet. It needs data to be smart. It also needs like the data to be accessed in the right way to be smart. But speaking of side projects, what I'm going to do is show you an example of running PromptQL on your own machine. All of the data is with you. If you head over to promptql.hasura.io/docs, there's a tutorial on how you can build an AI assistant on a GitHub repo of your choice and do some interesting things with it. So I'm going to look at a side project that we had from a while ago. And this is called a GitCube. It's an old project, an old side project that we built out for automating deployments and stuff like that. It's kind of cool. So let's build out an AI assistant on that and see what this experience feels like. So let me just stop sharing my screen for a second. And let's say, There we go. Cool. Can you folks see my screen? Zoom that up a little bit. Cool. All right. So, for all of you who want to try this out, please do make sure that you're on the latest alpha version of the CLI. You won't see this on a normal update CLI when you run it. It's not merged to stable just yet. Clone the repo, head up inside that repo, and set up your environment file. So I'm just gonna, I actually had an old one that I'm just gonna use to set up because that has all of my keys. What you'll want to do in this .env file is set up an API key, Anthropic or OpenAI. I'm going to use Anthropic for a bunch of this. And because we're going to be looking at accessing GitHub data, let's look at putting in a GitHub API token as well. So if you're looking at a public repo, you can just create a token. If it's a private repo, just make sure that when you create your token, you have the right kind of access that you have given it. For those of you familiar with DDN, DDN has kind of a more explicit metadata structure to it. So everything is laid out in your folder as opposed to implicit in the way that used to be on Hasura V1, V2. And what I can do is look at the TypeScript code that is being used to access and work with GitHub data. And let's go and change that to Hasura/GitQ, which is the side project. And once you're done with that, you'll want to make sure that we have a project that we've created as well on the cloud. This is required because the runtime for what for how PromptQL processes its queries is a service that runs on your account that is connected to your account. So I'm just going to go add that project. Awesome. And then let's just do a build. So to do. I'm going to head into a different tab here. And let's see. And then do a run docker start. So this is going to start up the PromptQL playground where we can start to kind of look at user assistant. It's going to start the engine. It's going to start the connectors. And it's going to start pulling in some of that data from GitHub into, and everything is going to be persisted on your machine. Nothing is going to be kind of running outside. This is a great example of showing you how things can go wrong. And one of the things that can go wrong is that Docker gives up on you sometimes. So you can see that my Docker on Mac has switched over to resource mode. This is a great demo of how not to use Docker sometimes. So I'm going to do a force quit. You can see that I've already searched for Docker because this happens to me way too often. So I'm going to force quit this. That's great. Let's start Docker again. All right. And so this is going to kind of pull in our services and run logs for us. So we can also kind of just see, what's happening. So it's starting to kind of pull in some data and then you can see kind of that data being pulled in here. And let me, we'll start the PromptQL playground. We'll start in a bit as well. Let's just do DDN console -- local. And I'm going to take this URL. And we'll run it on our browser. All right, and that's our assistant running live. You might notice it takes a second or two for the API for PromptQL to come up as well. But then as soon as that does, you should be able to say hi to your assistant. And your assistant is going to tell you things about what it has in its metadata. So in your supergraph, you have metadata that describes all of the different entities, all of the vector data, the structured data, everything that's there. And that's what the assistant has access to, right? So this is powered by Anthropic. And so it's telling me, hey, what do you have that's related to GitHub issues and comments? And so I'm going to say who are the top issue creators on this repo. and so it shows me the query plan, right? So it's gonna look at GitHub issues. You can see the code that we have that's synchronizing this, and then you can modify this. This is just a Git repo. So this is in particular pulling in issues and comments and pull requests and stuff like that. And that's kind of what it's looking at. And it can kind of tell me what is happening, right? So let's say classify issues by the top creator as just classify them. Tell me what kinds of issues. Tell me what kinds of issues they've created. And there's 40, so maybe I want to look at 10. Let's look at the 10 most recent ones, right? And so I can kind of start to get an analysis of, what's happening. I'm not worried about saying things like top and, it screws up what the meaning of top is and it thinks top is something else and it doesn't know what first and second is, right? Like this kind of stuff that we've always felt a little bit scary about, or we've worried about time, right? We don't have to worry about those kinds of things. And Paulius, to your earlier question, structured memory, right? This is structured memory. This is what you're seeing. This stuff here is not in context, right? This content is not a part of the context of this conversation that I'm having. So this content, if I'm looking at tickets or issues or whatever, it can be millions of entities long and it's totally fine. And I can do analysis. So let's see. So it did a classification of different kinds of classification that it did. And this is what it classified it into. I don't know whether it's looked at labels or not, but I can ask it, did you look at labels? Did you classify it yourself? I can look at a detailed execution plan as well. So if you look at the execution, you'll see how it kind of composed that query together. But I can also classify it in different ways, right? I can say like, hey, look at the comments as well, because I noticed that it just said, it looked at like issues, including the title and the body. Didn't look at comments. Look at comments as well. And classify them as positive or negative, right? And I can expect this to work without it screwing up, right? And so this is kind of a quick feel of what this looks like. You can get started with this. You can deploy this to cloud. It'll to the cloud as well. This will work. You can share it with other folks on your team. And this should work with any kind of data that you connect it to. And so we'll be doing a lot more demos and examples over the coming days. There's a ton of stuff. I will hand it back to you, Rob, to see what it's doing. Just one quick note as you folks try this out, please do remember that it's an alpha. Things are a little bit unstable, so do feel free to hang out on our Discord and chat with us. And your feedback obviously is going to help continue making this better. Good job also, side note to Thiru from many years ago, who is a contributor to GraphQL engine PromptQL as well. He built out the eval set. And clearly he's been very active, or had been very active on GitCube. So that's me. I'll be hanging out on chat as well, but back to you, Rob.
I was going to say, Tira's been screaming in the chat of, no, quit putting all my issues out for everybody to see. I have better questions for you, so I'll let you two work that out. All right, folks, let me share my screen here. So we know that not everybody's going to be focused on the development side. Obviously, we're very excited about seeing the GitHub portions for this, for being able to bring that in as a connector. Side note, I actually connected one of my open source repositories to it and had to analyze all the issues and just say, hey, like, where can I make some simple improvements to like my README as an example, just based on these issues that have come through. And I've already got some good things that I'll be taking away from me. So thanks for that, folks. I'm going to turn it over next to PromptQL's PM, who is Anush, and he's going to be talking about efficient customer support with AI. So we'll look at a little bit different use case here and see even how these agentic data access tools can take action for you as a user. So Anush, over to you.
Thank you, Rob. Hey, folks, I'm Anush. I'm the PM for PromptQL. So let's look at another use case. So let's look at how PromptQL has helped us, our internal customer support agents, with their day-to-day work. So let me share my screen. Okay. So this is a live agent running for our internal customer support teams. This agent is connected to a bunch of different data sources. It is connected to a bunch of our internal data, data about our users, the projects they have deployed on Hasura, all the finance data, how much we have built them and stuff like that. And also it's connected to our ticketing system, which is Zendesk. So it has all the customer support tickets and stuff like that. So now I come in the morning, I want to ask some question, and I want to treat this like a human being. So if I ask it something like, who are my 5 most important customers? Maybe look at the revenue, figure it out how you will calculate it, how to calculate it. Yeah, calculate the revenue. Also, tell me how many projects each of these users have. Also, how many tickets, support tickets they have. Right. So like a complicated query with a bunch of different data from different data sources, instantly it starts to figure out, okay, for me to answer your question of who are the most important customers, you say, look, take a look at revenue. Revenue number exactly doesn't exist anywhere. So what I'll do is go take a look at like the finance data. I'll look at all the invoices that have been generated. I will group all the invoices for each customer. I will look at all the invoice amounts, sum them up for each customer. If I mess up, I'll retry. And then I'll also, for each customer, I look at all the projects that they have created, all the support tickets they have created, and give you a complete analysis on that. All right, so there you go. So these are all my 5 customers. This is the total revenue by them. These are all the projects they're running. These are all the tickets they have raised. So you see how it flexibly figured out what I need to do. If it messed up somewhere, it figured out what the issue was, fixed it, and gave me a very detailed insight into all of this. So this kind of reasoning capability, right? This is what we call agentic data access. Just figure stuff out based on my vague query, no matter how complicated it is. So now let's see, let's look at one of these customers, right? Let's say this person seems important. They have 5 tickets. So, okay. Can you get me the details of all the tickets by the 3rd user? Now, as I say, the 3rd user, right? Again, it doesn't have to remember who the 3rd user is. What it'll do is the first thing it does, right? Like, which is I'll retrieve the 3rd user's ID from the previous artifact, this structured memory artifact that Tanmai talked about. So even if I was doing an analysis on 10,000 users, it doesn't have to remember stuff. It'll just retrieve it from its memory, and you know for sure that that customer ID, that email ID was correct, not hallucinated at all. Okay, so these are all the tickets closed. All of them are closed. Okay, makes sense. These are subject, description. Okay, there's a bunch of things for me to process. Okay, I just want you to help me out. Can you summarize all their tickets? Also include the comments on each ticket. All right, so they'll retrieve all the tickets from Marissa. They'll also fetch the comments. Then you'll summarize each ticket, makes sense, and then give me a comprehensive summary. That makes sense. Exactly what I want you to do. All right. All right. You generate a text artifact, an entire summary of things for me to look over. But now, can you classify? Actually, like fetch the details of each ticket, including comments, and classify how well they have been resolved. And don't just give me a binary classification that resolved or not resolved. Like, be more nuanced, like create 5 categories. All right, so you'll get all the data, prepare the data, define 5 categories, makes sense. Use a classification model to categorize each ticket, makes sense. So as Tanmay mentioned, like not doing everything in, not dumping all the tickets into one LLM context and then just asking it to give me a summary. Just do it for each ticket. Do it step by step. Okay, if it messed up retrieving some data from the artifact, it goes back to the database and fetches it from there. And let's see what happens. All right, so these are the tickets, subjects, resolution quality, well resolved. Okay, that makes sense. Perfect. Also gives me some insights and observations on how well they have been resolved, why they've been resolved, things like those. But now let's say I want to take some action. I want to do something like, so each user has multiple projects, right? They had 7 projects, I think. So for this user's highest revenue project, issue $500 in credits. All right, so I'll try to figure out what are all their projects and then identify the project with the highest revenue, and then they'll issue $500 in credit. Make sense? That's exactly what I wanted to do. Okay, makes sense. It requires an email as well. If the variable is not available in context, let me just go back to the database to figure it out. Yeah, so just like a human would, right? They take multiple attempts, they mess up, they figure it out, and then they continue with it. All right, so it's about to issue credits to this user, this much amount to this specific project ID. Makes sense. That's what I wanted to do. So one thing you notice is that when it's about to make a permanent change, right? When it's about to make a mutation, it stops and asks for a user confirmation. So so that you don't want to give your LLMs free rein to make any kind of changes that they deem fit. There you go. So it for this user for that specific project, $500 issued, and gave me an invoice ID. So this basically shows how you can have multiple complicated data domains connected to your AI. You can talk to it, figure it out, do your analysis, do bulk operations, do compute, and then also take action with it. So yeah, that was a quick demo on of our internal assistant that we have for our customer support team.
Awesome job. There's a lot of questions that are coming through in the chat. Very cool at the end there to see, especially the agent taking action for a human. You can imagine how that would scale, right? And especially for all the different various sources that you can connect. It's pretty revolutionary, I think. Thanks very much, Anushrut. I'm going to go ahead and... All right, folks. As we have seen the links today, we've got the resources for how you can get started with all of this inside of this webinar. So you can go ahead and jump on and start trying things out. Give us your feedback. Let us know how things are going. Additionally, we have Discord office hours. And you'll also find a Discord link on the docs as well for a particular channel that we have on our server. So if you want to come in and talk about things there, get help, share ideas, anything like that, we are looking forward to hearing from you. Additionally, every Tuesday at 10 a.m. Pacific, we had Discord office hours. And again, you can join the server and stay up to date on everything happening with PromptQL and DDN as well. We're always looking for feedback in various ways, whether it's just the Hasura community, whether you would like to be on one of these community calls and do a demo for whatever it is that you're working on and building with Hasura, and maybe now PromptQL. And then again, also our Discord is there for you. Thanks so much for being here. Again, a happy Halloween, a happy Diwali, and we will see you folks in the next call. Thanks.